Hi, it's Gadget UK here again, back for the second part of the GBA1000 build. Huge thanks to Conrad, as I said in part 1, for sending me the motherboard, but there's going to be a lot of thanks through this, and it's kind of turned into a bit of a community project. So many parts and stuff came from so many different individuals and what have you, and tools and everything really that's gone into build this. Anyway, picking up here in part 2, just starting to solder some of the sockets and things on. We covered some of the case stuff in a couple of Patreon and YouTube member exclusives. If you want to see a few behind the scenes on this, it might be worth checking those out. Yeah, so the CPU socket here, it's pinned in 2 places, but I'm just going to pin down here and then press it from the other side. The reasoning for doing this, well, is this is the time-consuming bit, soldering all these 100 million solder points. You may think it's sticking all those SMD things on, and yeah, they're a bit fiddly and they do take time, but they are easy compared to the 100 or more solder points on many of these ICs. And I've checked the pin out on that, it is the right way around, so I'm just going to commit to soldering on. What I do like about this board is these gold plated pads and the shape of them. Wow, they're so easy to solder. They really are. This is probably the easiest thing I've soldered in quite some time. The solder flows really, really well. You can just get into the zone and just fly along them. Yeah, and I'm still cleaning up as I go along here, just to make the board clean to handle really, because I'm going to be at this for a number of weeks, I would think, just on and off as different parts arrive. Yes, I've gone all around the inside and outside there, but you can't obviously get in between the pins. So what I've been doing with things like this is, well, just fold the paper towel like this, cut out a little shape of a ship. There we go, test it out for size. That's not going to be bad, is it? Yeah, Noel's Retro Lab inspired. Because I've just found that this paper towel, if you do this, I mean, this is my idea to mask off around it, but I'll show you in a minute. The thing Noel does is actually to put I think he uses a cloth or something, puts it over and then scrubs it. And that works really, really well after you've done your preliminary scrub here like this. But I'm doing this just so it doesn't splat absolutely all around the whole board, because I'm doing it bit by bit. The board is so big, I think that you get a much better result by doing it like this. If you wait to the end and clean it up, you'll be at it quite a while and have lots of flux to try and get off. Because, you know, inevitably, like when you're in an area like this, it's going to go right off the edge of the board, isn't it? You've got to mop it up somehow. What some people do is soak a board, in fact Stephen Lewy does that, soak a board like this in a big tray. Get a tray that is exactly the size you require, but this is the thing, Noel's Retro Lab here, this works incredibly well. It really does with this paper towel. And don't worry if the paper towel moves like that. When it does move, that kind of aids the cleanup process. You do get the odd particle, you can see, actually I think that's pretty clean already there now. I will then typically just give it a brush with this. It just kind of polishes it really. But we've protected the wider area. There's just the odd bit here where I'll just clean the wider area. It's mostly fingerprints and things really. Yeah, and if you look at that now, that's pretty good. That's pretty good. Obviously, there's 2 other components to fit there. I can't read the Silkscreen. That is going to be a problem with this because, well, I don't know what to fit there. That one there looks like it says something R82, presumably R82. And the one down here, something 3. Could be a 6, could be a 2. I don't know. So, that's a problem. That is a problem. I could refer to the schematics, and that's what I'll probably end up doing. I've got Stefan sent me that. It was incredibly hard to find any information on this, but Stefan just happened to either know somebody or have all of the JEDEX, the equations. But he also had, I think, several pages of schematic So I can look at the schematics and go, what resistor needs to be around Agnes here, because this is Agnes. So yeah, like these are soldered on, the caps here, the sockets here, those, we've just got 2 resistors missing. I can solder that on perhaps next. We've soldered here, I need to clean around that next. And I've done the 2 caps there, again 2 resistors required. And I do have the resistor, so I could start to fit some of those in a little bit. I'm not in a rush, I just want to get the thing with volume here, you know, the capacitors, that's what I'm focused on, the 100 nanofarad caps and sockets. I'm not going to get any chips on it well into these sockets until we're near the end. But unfortunately we will have, you know, some SMD ICs soldered in place, so I will need to be careful handling the board. Right now I don't have my wrist strap on. Technically I could damage some of these caps. There's loads of these little SMD pads, you know, like tiny little wires. You can see 2 or 3 of them up there, maybe, from a distance. And it's really hard to avoid getting solder onto those. But what I will do is when we come to fit any electrolytics on this board, and I think the original design doesn't have them, but I'm going to fit them anyway. It's all tantalums, I think, in the design. I don't want to do that. I'll fit some tantalums on there, but I think for the main capacitors, where I can, I will fit electrolytics or polyester or hybrids. And when I do, I'll block any wires that are anywhere near the vicinity of the capacitor. Anyway, that's pretty clean now, so I could just do the same thing, just mask. The nice thing with doing it this way is I feel like I'm actually achieving something instead of feeling defeated. And I'll be honest, it's taken an incredible amount of, what's the word, determination to start on this. And even when I started on it, I'm like, I don't know whether I want to continue on it because there's just so much to do. So by doing it like this, just getting on with it, just doing what I can, bit by bit, even if things don't make sense in the order, it just means it's progressing no matter what. And then eventually I'll just get to a, wow, I've completed it. And I guess the further you get along, the more motivation is to finish it off. That's my thing with this. So I could imagine if I didn't do this, it could be one of these things that just keeps getting touched occasionally for, you know, a few hours every few months. And like 5 years from now I haven't finished it. That's it. That's looking pretty blooming good again. Yeah, hopefully you'll agree. So, I need to solder that next, don't I? And we've got another PGA chip up there. Just mounted 2 there. So, yeah, the way I do these is, well, inspect like this, fit them, and then inspect the silkscreen according to the actual edge of the socket and them to each other. I've pulled them intentionally downwards here because obviously these sockets are going to go here, and I reckon they're going to be almost touching here. So I want to make sure they're as far away from those as possible, and down that way as much as possible. That's 2 on. And do inspect all the pins are in. You know, you've not got a pin missing or it's not, and make sure it's flat and flush. And yeah, get these ones in. But I'm going to need to order more sockets and things because, well, as I mentioned earlier, I'm out of the 20 pin ones already. I need another 6 or so at least, I think. And yeah, just do the same thing, pull down towards the edge of the board here as I solder these, and then just inspect to make sure it is straight. Yeah, that's not too bad, I don't think. And once I've done these, I will get the caps under these as well, actually, do that whole area. Again, really tight here, but you know, with a really fine tip, I can fit those components. I'm not going to be struggling at all. And when you're holding the board, try and position it in such a way like here, where it's nearer to where your hand is, so that you can hold and solder and feed the solder. Like, granted, that's hard in the middle of the board. And what I do there is position the solder at the right place before I start soldering, if you see what I mean. So if I was soldering something over here now, I would get the solder like this and sort of get it approximately where I want it, and then I can just heat the pin and, you know, holding it at the same time, if you see what I mean. But I'll solder the caps before I solder all the other points here, just because, well, the caps are the harder thing to do. So I'll just have a quick look at my cap list here. And these are all the parts I haven't got, but I do have some 1206 100 nanofarad caps. Maybe not enough, because you need about 100 or so for this board. I reckon there's about, I don't know, 50 or 60 here in total. So I am going to be needing to order more. So the ones we're dealing with here, where we are at now, we're here. Yeah, so we got C70, 71, 72, 73. C70, 71, 72, 73. It's kind of what you'd expect. For most of these, the coupling caps are going to just be 100 nanofarad, but there's a lot of different sizes of caps for this board. Granted, many of them are probably going to be on the video audio section, you know, on the de-interlacer, etc. Hang on, it's just torn. Oh, what's going on here? They're popping out all over the place, look. Yeah, I'll show you some work on Kavanos Cam in a minute, but I'm just using the magnifier from my parents at the moment. And it's pretty hard. You could argue get these on first, because it's hard to go getting them over the gaps of the pins when you've got pins in the way. If your cap is not, you know, already where it needs to be, trying to get it into that gap. That's actually made that look really hard, and I hated that for ages there. Let's just try and slide this one down here. Yeah, here we are, so 71. It's just to bung that in. That was a good throw, wasn't it? I've got the tweezers that Kevin sent me, and I've been using those for a few things recently, but here, well, I just find it far easier just to, let's say, bodge it around like this. Hang on. Oh, where's it gone now? The problem is, you see, because I'm trying to show you, suddenly it's got really complicated. That would normally be on in no time. It's actually harder to use the microscope than it is just a magnifier. Yeah, you can see that's not too bad. It did get a bit. Oop, hang on. It did get a little bit more baked than I would have liked, but that is a consequence of using the microscope. The microscope's great, it really is, for specific things. You don't always need the microscope for everything you do. Oh, let's get rid of that. Yeah, again, it took me a lot longer than it would with the magnifier. Again, should flow with a wee bit of flux there. A bit too much solder on that one. Anyway, that'll do. Yeah, can you see these? These don't look as baked as the two I've just done, because these were on really quick. Those other two just got a little bit cooked, I think. I mean, it might be the flux that's made it go that colour, I don't know. Anyway, you can see that. Maybe that's not very straight. And this is really pedantic because, well, do we really need to clean up the solder points there? And probably not. It doesn't really need to be a Picasso, does it? Anyway, I'm not going to clean up there just yet until I've soldered all the remaining points. I'll solder the legs here and then I'll have a clean up. So this is another one of those builds that there's just so much to do. I've skirted over so much. You can see it's starting to take shape. There's lots of things on here, but still so much to go on. I've just got that ID connector. I think this was something I reused from the Prelude. I think we trialled out a connector like that on the Prelude and then I swapped it. So I did have to just level one or two of the pins here and get the solder off the solder points there before fitting it. But it lives on this board, and I've got a 50 MHz crystal there, which was reclaimed from something in the past. That definitely works. I've got this pin strip here. It's the finer pitch. Forget the exact... it's not 254, it's smaller, but it came from Live 2. That it came with the Spitfire, and I didn't need it. I don't know why he included it, but anyway, it's coming on for this. So I'm just going to cut this down so it's exactly the right length for the alternate ID connector there, and we'll fit that. Yeah, just trying to measure it up. Just going to just trim that off. Please stay in one piece. Yeah, there we go. So I'll just file the end of that down a little bit. But that piece is good enough to use as well for something. Yeah, and it is pedantic, but yeah, wherever you've got like burrs and things like that, they just look an eyesore. It's always worth just spending the minute or so it'll take just to smooth that off and make it look like a properly manufactured piece. Yeah, would you believe it? It is 2 pins too big. How did I do that? I don't know how I did that. That's what you get for just doing it by eye. Hold the solder in the right place like that there. Get a solder point. And do the same up here over this side. Both of those IDE connectors on. Yeah, if you have a look at those 3 chips there now, that's not so bad. So we've just got 4 caps that are missing there. Yeah, doing some more caps here. You can see one of the problems with this, as I mentioned earlier, like the Silkscreen, that C13, is that a 3? What else could that be? C13 something, C10, C8, I don't know what's happened to the middle of it. This is this thing that makes this really, really difficult. But, just using a bit of common sense, just check, this is a 100 nanofarad cap, so I thought let's just check from here to here. Yeah, I'm just got a bit blurred, let's just try and focus a bit better. Yeah, so those sides there are joined together, dead short, and those sides there are joined together, dead short. They're both in parallel, so it's going to be either, I could put another 100, and have 2 100 caps there, 2 100 nanofarads that is, or I could put a different size, like 10 nanofarads or something like that instead of 100 nanofarads or something similar. So because there's 2 different sizes in the schematics, and yeah, I think that's what I'm going to do. I'm going to assume that that one is one of the 10 nanofarads instead of 100. And I don't have a socket either for this. This is the FPU socket. And don't have a CPU socket either, so I need to order those. There's so many bits I need to order. And I changed my mind there because I couldn't actually read the part numbers properly. That's like, looks like C121, and looking at the bill of materials, that's supposed to be 100. So I figured if that's got 2 100s, this is going to have 2 100s, and it's because they've got separate VCC pins. You know, there's more than one VCC pin on a 68030, and it's the same, I think, on a 68882 or a 68881, which is what I might have to fit there, because trying to find a PGA 68882 is probably not going to be that easy. So a huge jump cut. As you can see, I've got so many things socketed here. That's not soldered on, that's only anchored on with about 6 solder points, and this is only anchored on with a couple of solder points. I figure what I might do is to remove that. That's why there's only 2 points there, just to get access to these other resistors around things and caps and things that I'm managing to do okay. I've had to order another load of parts for this because I didn't have any of the inductors, any of the capacitors, and lots of other things, bits of sockets, chip RAM, etc. Over £100 spent on the second part of the order, so it's like the total build for the parts so far for this are about, they're over £200, but I've done it over, 2 years, because I got this board more than 2 years ago, and every now and again I would order some parts. But anyway, I thought I had everything and I didn't. I still needed £100 of parts, believe it or not. Anyway, the resistors, I'm going to fit one of them. I'll show you the first one. Yeah, and it's a crazy MELF resistor. Yeah, MELF, not MILF. MELF resistor. Hang on, let's try and get focus on this one. All right here. Yeah, so it's round. If you think of the diodes on a 4000, you can see it there. Like it's like a little, not round, cylindrical thing. This would be one, because there's one 150 ohm resistor. I thought I'll start with that one. That's the one that was first out of the bag. And just looking, it goes right at the end of the board here to the composite connector. Oh, hang on. I assume it's actually for the composite. I can't even pick it up now, it's so small. And I'm going to use cav cam and cav tweezers here. So let's just focus on that. I'll try and find the tweezers again now. Yeah, I had a nice blue floppy connector and a black IDC, for the IDE, and it's vanished. It's absolutely vanished. I've been everywhere. I've looked everywhere. I've been every single drawer, every single bag, every single box, every single shelf. I have looked high and low. It's just dematerialised completely. I must have spent an hour over the last 2 days. Every now and again I spend 10 minutes having another look for it, looking in all the same places I've already checked half the time, which makes no sense. So what I'm going to do here is just get a bit of solder onto that pad there, and I've got crazy tips still. It's giant. This is the one that came from Brian in Denmark. And it's been really good for everything apart from these small things. It's just a bit fiddly, but I've managed it. It's look, that's stuck to that now. Hang on. Yeah, I've managed it. And this is the thing, you've got to get the right angle. I've got to sort of twist my arm in a natural way here to get that to bite. And then if we just move it around a little bit, well, that'll do, I think. It might be slightly further up towards the point we've soldered rather than the bottom. And it looks flat. So I'll just come in and add a bit of solder there, add a bit more flux to this side. That's not too bad, is it? And clean up. Yeah, so all of these resistors I'm going to be fitting now are all MELF ones, but funnily enough, I went back to DigiKey to try and order the remaining ones because there's a bunch of 4.7Ks I need to order. I ordered one, I need like 20. I don't know how I managed to do that. I must have missed the quantity thing or something, I don't know. So I had to order a load more resistors, but I haven't been able to get MELF ones. DigiKey have stopped selling them in 1208. Is it 1208 or 1206, this size? Which was really annoying because, well, anyway, we're going to have a few different types of resistor on it, but you can't really tell from a distance, you can't really see what's on it. These are so small. So it's no big deal. Anyway, that's that one. R29 is done. They're really easy to solder, these MELF components. I quite like them. You know, you get really nice solder points on either side. That block there's turned out to be a bit easier than I thought it was going to be, actually. Because there was so many of these 68 ohms, I thought, oh no, they're going to be all over the board, and there's a big long strip for the chip RAM, and there's another strip of them just down below where you can't see that I need to fit next. So yeah, and they come out fairly straight. One or two there on that one is a bit further up, isn't it? I did just try and reflow with hot air. I don't want to bake them. This is the thing. The other thing I'd forgotten about is all of these MELF components. The reason this first batch cost me, I think it was about £50 for all the initial parts of the resistors primarily, and they're all 1%, and I went with 1% primarily for the video and audio section, you know, because this has obviously got the scan doubler and amber side, so that's why I went with 1%, and I couldn't work out easily at the time which ones needed to be 1% and which ones didn't. Because the bill of materials, well, it's not that clear if you ask me. Anyway, so these are all 1% components, and I think I was only 2 resistors short, which I've had to order, which are probably like, I don't know, 5% jobs, and I think they're on other things. So actually, I think the video and audio section should be pretty tidy on this. You can see I can't get between the gaps there. So once I've done that bank there, that's the bank I've just done. Once I've done that bank of resistors there, then I'll do my little mask off thing with paper towel and toothbrush around there. Bear in mind, we're going to be fitting the RAM yet as well, and I ordered all that sort of stuff yesterday, the RAM and the other bits and pieces. And I'm just going to have a little scrub with a toothbrush, just get in between and around those. That's not looking too bad at all. Right, let's test these transistors that I took off the... In fact, let's give it a strap on. Let's not tempt fate. Yeah, I took these off the 500 plus board from hell that we've replayed into ports and various other things, you know, crystal and what have you, and the 1488, 1489, and the op amp. Quite a lot's come off that board. N channel, junction FET, there we go. Drain and source not identified. Well, it's worked out what it is, but it says drain and source not identified. That's a bit worrying. So anyway, let's just unclip that one. One of these is a 3904 or a 3906, I think, I forget. And I think we need a 3906 for this somewhere. My hand-eye coordination is terrible just now. So let's do a test again and see what that comes back with. PNP silicon. Yeah, so that's the transistor. No, it's an 06. We need one of those, so that's good, I think. It's nice the way that I've been able to use so many original components here. I mean, not just the chips, like some of the transistors and the 4888, 4889, etc. NPN silicon. I must have another MOSFET somewhere. Oh, I see it over there, yeah. So this one's going to be an 04, isn't it? I'm not going to check the specs of that. I'm just going to assume that's probably alright. Yeah, that's an 04. I guess you can get different types of... there you go. And let's see if it says... Yeah, same thing. Drain and source not identified. So for whatever reason it can't identify the drain and the source on that. So yeah, we got position here for what three transistors. And in fact that's it. Those are the only three positions where I see transistor designations. So one of them's a 3906 and the other two are the FETs. So I'll fit those. So more more MELFs. You can see how hard it is. I can't even open the flipping thing. I mean, alright, it's not focused, is it? But oh, I so hate these little SMD things. SMD's easier to solder, I think, for me. I just hate fiddling around with it, trying to open things, trying to get the things out. There is 4 there somewhere. So I'm doing 95, 96, 97, 98. We've also got 99, 100, but I'm just doing those 4 for now. Let's just move these down. So, where are we? I think that's 95. You've got to assume, because 96 is next to her. Hang on. 95, 96, 97, 98. And then use cap tweezers. Try not to melt the connector. Hang on. I want to get the iron in that way around. Oh, is there a hair there? What's that? Oh. Let me just turn the board a bit. Yeah, the angle of the board is everything when you need the angle of the tweezers. If you see what I mean. It makes it easier when I'm using my left hand. Hang on. Am I touching the port there? No, and the MILFs are all running around the place. They're all over the board now. Oh, that touched the connector. It was just like a little light touch with me laughing. I've got to stop laughing while I'm trying to do this. MELFs running everywhere. And I tell you what, if I never work with MELFs again, it'll be too soon. There we go, that's one. Got to try and find the other ones now, they're wheeled off. It's the problem with the cylindrical things, they roll. There we go, they've rolled back over there now. And, furthermore, I got no spares of these. I got just the right count, because they're expensive, these are 1%. And granted, I didn't need 1% here, where we are right now. Let's just get that out of the way. Yeah, normal tolerance would have been fine for here, but you know, it's like I said, it wasn't. Checking to see which area of the circuit these were in. I just know there's a load of them for the audio section, a load of the video section. There you go. It takes me longer because, well, I'm in the pursuit of trying to get them all nice and straight. And they're probably still not straight, but you can heat with hot air. I've done that in 1 or 2 places just to reflow. When you add the solder and flux at the same time like that, you get that really nice flow look. But when you pre-solder, well, and then heat up, you don't, unless you've got dedicated flux. But I just, I've been doing this all and just reflow that side now. Just adding a bit of extra because, well, just makes them look better. There we go, that's those done. And a bit more detective work, trying to find R3. There's something here that looks like an R, you can't see it from there, it's a squiggle and then there's a 3. So I just looked at the schematics, I think it was like page 4 or page 3, and R3 is under Agnes, this is Agnes here. So that's going to be right. When I say under, on the schematics you can't tell it's under, but what you can tell is it's on Agnes and it goes to one of the pins here, 22 ohms, so yeah, I can solder that one there now. I'm having to do that for a few of these, just try and work out what's supposed to go where. Yeah, just a reminder, the negative on these caps is the band. The BOM actually specifies tantalums for all the main capacitors. I'm not fitting tantalums. I don't like tantalums everywhere. I will fit one or two, but what I will do is just block any wires that are nearby and then just fit these, which are good branded caps that I got. I think the Panasonic or something. So yeah, I'm getting in a bit of a mess here. I've just got these from eBay, yeah? No receipt, no invoice, no nothing written on it. What are they? The caps, I think. But what size? I don't know. I'm going to have to measure those in the meter. It really annoys me when people just put things in an envelope with no description of what it is. And then I got some little SMD SOP. They look really small. They might be too small. They look like SSOP. But anyway, we might just be able to squeeze that onto the footprint. I think actually, if I just move this out of the way, it's for the underside, wherever that is. This, yeah, here. It might fit all right. There. It might be that one. There's another one somewhere. Well, there's the 245s as well, but anyway, we'll get that on in a minute and we'll work out what those caps are. I've got some of the tantalums here that came from the reuse, you know, the taken off heat damage one of them. Can you see? Yeah, I'm not going to use that one. It's a bit baked on that corner. I removed them with hot air. You don't need to do that. You can just use a bit of dissolved abraded flux and get them off fairly easily that way. But I fitted, as you can see, a bunch of caps on here. So 47, some 100s, I think, and a 47 or something like that, and then one up here, and then some tantalums. These two I'm going to have to take off. The reason being, I fitted all these and I was looking at the marking. There's a band marking, can you see here? That indicates the positive on a tantalum, and these tantalums, if you look at them, they've got a stripe that indicates the positive, not the negative. So these, the negative, is indicated by the band. And I swear, I connectivity tested and then fitted everything, and then got to the point I was up here, did those two last, then I was like, hang on a minute, I started doing some checks and found that every single cap was on the wrong way. So I'd take them all back off, and then I've put them on and tested them as I'm going along. So I think everything's right, apart from these two. So I need to test that with a multimeter, and I'll show you that as well. But it's confusing because one of these down here is on, I'll show you that now, is on the, I think on the minus 12 volt rail. Yeah, and we're missing ferrites, which again complicates matters, because if you were to measure from here to the power connector, there's no join because the ferrites aren't there. So yeah, it's one of these when you try and do things the way I'm doing, bits of things in no logical order, it can be quite difficult trying to work out what's going on. So if I measure from the ground plane down there to say here, hang on. This is the thing, why am I not getting a good ground there? I don't know, that's the ground. So that's okay. If I test the other side, yeah, not ground. The next cap there, that's ground. So those two are the right way around in respect to ground. This one here, the negative side is not on ground. The positive side is on ground. So I was like, oh my god, is that one round the wrong way? Well, it's following the same designations according to the board markings, you know, the Silkscreen, as these two, yeah? So I thought, well, maybe that's on a negative rail. So if I find the other side of it, hang on. Yeah, so the positive side of it here, but it goes to, hang on, if I can get onto it. It goes to one of the ferrites right next to it, there, hang on. And the other side of that ferrite would go to, if I can get onto it. Yeah, the end pin here, I am guessing that's minus 12, and we can test that by going back to the point on the cap and up to the audio op amp here. The centre pins on this are going to be, I'm going to get onto it, minus, one of them's going to be minus 12, there we go, yeah, minus 12, which means the other side is plus 12, that's going to be this one here on its positive side, yeah, that goes there. So you've got plus 12, minus 12, plus 5. So anyway, you get the idea, and then just same thing with all the others. So like the one down here, its negative side is going to ground. The one up there, its negative side is going to ground. Those two, positive side's going to ground, look. Positive side to ground, those are around the wrong way. Those need flipping. Tantalums, where are we? The negative side is ground, that's the band at the top. The negative side is at the bottom, that's correct. So yeah, it's those two need swapping. I'll show you that, I'll show you removing those. Anyway, thanks to Caffers for the caps that we removed from his 4000 when we put proper caps on it. And you may be thinking, but isn't that a bit hypocritical, Gadget? You took the tantalums off his 4000, put electrolytics on, and then you're reusing his tantalums on a new Amiga board. Yeah, but this is specified. Every one of these caps pretty much is supposed to be tantalums. Yeah, I'm just doing what I do best, which is to think for myself really and go, I don't want to fit tantalums everywhere, but I will reuse some of these tantalums, the ones that are, you know, an ESR testing these. That one that was a bit charred there has got a slightly higher resistance, and that's why I don't want to use it. I'm going to put that in the bin actually. As far as I'm concerned, that one's toast. But it was because when I removed these, I used hot air. Just get some flux onto this braid here. It's useful because these are the mistakes that you can make. If you make a mistake like this, you know, this is the easiest way to get it off. You could use hot air, but then you're going to cook it. You're going to potentially melt things nearby. You're going to have to captain tape lots of things up. If you just remove all of the solder from the point there, like that, and I'll just try it and just lift slightly. There you go, it lifted already. And if we do the same on this side here, again, just sort of lift. There you go, it's come up. And then what we may need to do is just heat this side and lift. There we go, and then heat this side and lift, just gently, not a lot. And then that side is off pretty much, I think. There we go. So the cap is off, and then we can, you know, just mop up the remaining solder and get it back on the right way. So you can see the band is to the right there. That indicates the positive, and I don't know why. I was assuming that was the negative or somewhat like that. I don't know. I did do connectivity tests and managed to confuse myself. It's the problem when you're trying to swap from electrolytics, where the band indicates the negative, where it was supposed to be a tantalum, where the band indicates a positive. So anyway, I'm going to start on the inside point there, being careful to not melt anything nearby. You see what's happening here, let's just take that back off, is the solder underneath is raising it up, if that makes sense. So let's try that again. I'm just going to heat and slide it into position. There we go. And then get some solder on that side, quite a large amount. And then if I press that down, it just means that it sits flat then. There we go, it's flat on that side. It might not be flat on this side though. Let's just try and press and heat without melting my finger. That's it. So that one has now been corrected. Do the same thing with this one. And you could argue I should have took this one off at the same time, because, well, we might end up mopping some of the solder up from the other one now, if you see what I mean. So let's test on the Atlas. Yeah, I'll show you the screen in a sec. Yeah, it's got a good ding ding. The low ESRs, these 0.02 look 10 microfarad. So that's good enough to go back on. We didn't adversely damage it, and get it on the right way this time, with this negative away from the stripe. You could argue it's a bit crazy really doing all this clean-up work as I'm going along. I've used about 100 cotton buds so far, cleaning up pretty much every few components, you know, all at the same time. It just makes it cleaner to handle, and it just gives you a much better result at the end really, if you've cleaned and cleaned and cleaned as you've gone along. And I skirted so many things including that. So that actually came from an old C64 motherboard. That is the I think it's classed as a modulator output or something on this, but you know, you've got like, you can get composite out of there, but it is the DIN from a C64, you know, that's what they used. It's crazy, isn't it, really? One thing that did strike me about this, we've got an amber socket here, yeah, for our de-interlaced video. Where's the VGA connector? There isn't one. You've got to use this here, so I'm going to have to get a connector, plug something in there, have a cable coming off to a 15-pin ID connection, which I'm going to have to mount somewhere. I might mount that somewhere under where the power socket is, because there's quite a big cavity where the power cable goes, and I'm going to have a tiny little DC connector there. So I might dual purpose that and have VGA coming out of that, as well as the DC in for the power supply for this. But we'll cover that in another video. 74 AC08, so it's 74 series. The AC stands for the A, advanced CMOS, advanced CMOS I think, so it's going to be fast and it's going to have more capability of driving higher currents I think on the output pins or I/O pins. And an 08, I think it's an AND, isn't it? It might be a NAND now I think about it. In any case, that is going to go here. So yeah, you might enjoy watching me try and fit this here. This is the thing, and I think I've soldered that. Yeah, I've soldered that in entirety now. So yeah, it's going to be a real challenge to get that in. But using a microscope, CavCam, I don't think we're going to have a problem. It's really good practice though. This is why I like to do it. I like to give myself a challenge. If something's not hard, it's not worth doing. That's the way I say it. Hang on. There we go. So I've now got to try and anchor that without moving it. And this is where I really should have the fine tip on this Heiko from Dermot Sweeney rather than the tip that came from Brian. But this tip from Brian is really good, so I'm just going to try and stick with it and just see how I get on. So I'm being very careful here. I'm trying to get the solder right near and down onto the pad. There you go, you could see it actually move the chip a little bit when I did that. So I'm just going to do the same thing again here. Just heat that. There we go. I want to just move it marginally up. That's it. That's pretty darn central. And then we've got this plastic socket here to avoid. So we'll just come down onto the pin like this here and just a little bit of solder. There we go. That's not bad, is it? And we've got pin 1, the pin 1 marking was there, the silkscreen, you know, on the semicircle on the silkscreen. So let's get a wee bit of flux. And this is the thing, you see, it'd be easy to fit, easy to clean, easier everything really, if that cap wasn't there, if the socket wasn't there. But I like to do things in a way that makes no sense, where if I've got the parts in, I will try and fit something. Let me just rotate this. Yeah, and what I mean is these parts, well, I'm still waiting for lots of them. If I would have just waited, and I can't wait, I haven't got time to wait. I work 24/7 pretty much. So when I can do something, I'll do it, even if it makes no sense and makes other things a little bit difficult. So yeah, we'll just like try it and come down here. Let's just reflow gently. Because it's not fully anchored there, that's why I went a bit slower on those pins. I wanted to give time for one of the two of the pins to, you know, solidify, you know, the solder to solidify. I'm getting an awful result there, aren't I? Who was it sent with this microscope? Cavanos. You're making me too much of a perfectionist now. I thought I was a perfectionist before. Now I find myself like going over things half a dozen times because I'm not happy with how it looks on the microscope. It's like, see, did you see what happened with that? It's like it's smeared. There's just not enough flux there. Let's get quite a bit of flux around that. Get rid of the solder off the iron. Yeah, using a wet sponge. I haven't been using a wet sponge for quite some time, but now I use it quite a lot. There we go, that's not too bad. So you get the idea. We just need to do the same thing on the other side. Let me just rotate it marginally. This is going to be the challenging one. Right, that is most of that off, but not all of it, so I am going to toothbrush it. You can see there's no residue, it's all gone. All of that flux is gone. It's just the lighting that makes this look weird. If I turn the lighting down on the thing, you know, you can see that's kind of like more representative of how it would be. I know that it's not very well lit there at all, but yeah, that makes it look wet, but it isn't. If I put a cotton bud on it, you can see there's no smears, no nothing, there's no flux around that at all. Maybe a bit there. Yeah, there is just a bit of moisture there. But anyway, if I just move the camera over, that looks good, and that socket is good as well. And if I tilt the board slightly on its side here and we focus, you can see, yeah, we didn't touch the side of that at all. You're just seeing reflection of the pins there. Let's try and Focus a bit better. Yeah, that's all looking good. Yeah, so the video was running on a little bit long. There's still quite a lot more footage, like 130 gigabytes of it. The next video, I'm going to be speeding up some of the build process, like I've done in this video here, really, but, you know, otherwise we'll be at it forever. But as per this video, I'm just going to be, you know, points of interest, really. So, you know, in the next video, you might expect more montages, but just like in this video here, the bits where I talk about things is just where I've had specific challenges or issues or things that might help you out, you know, because there are a number of problems I run into as I continue to build this, as you will see in the next part. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please do see the Ko-fi and Patreon links down below. Every dollar means we can keep doing these videos. Massive thanks to Conrad for the PCB. Thank you to all the people I gave thanks to in the annotations and you know, vocally as well in this video. So many people have helped this come to life. I hope you found that interesting. I'll catch you in the next video.